Routing is the process of moving data from one network to another, and routers are the devices that make this possible. If you want data to travel outside of a LAN or across the internet, you'll need a router. Routers operate at layer 3 of the OSI model, which is the network layer. Think of routing like using a GPS. The GPS provides directions, which is essentially your routes, and the homes you travel between represents different networks. Routers operate at layer 3, which means they use IP addresses instead of MAC addresses. Unlike switches, routers don't flood unknown traffic. If a route isn't in the routing table, the packet is simply dropped. The routing table is the router's map. If there's no entry for the destination network, the data can't be forwarded. Why does routing matter? Routing gives networks a sense of direction by guiding data to the right destination. It helps devices communicate across different networks, whether across the office or across the world. Most importantly, routing allows networks to scale. As your network grows, routers ensure everything still connects smoothly. With routing, you enable inter-network communication, allowing different networks to access each other. With routing, there are different types of routes that can make up the routing table. Some routes are added automatically, like connected and local routes. A connected route is to a network attached to the router, while a local route is to the router's own interface IP. Another type is a static route, which is manually configured to tell the router how to reach a network or device that isn't directly connected. Finally, there are dynamic routes, which are learned automatically using routing protocols like OSPF, EIGRP, or RIP. We'll dive deeper into those in a future video. What is administrative distance? Administrative distance, or AD, is how a router decides which route to trust when it learns about the same network from different sources. Each type of route has a default AD value. For example, directly connected routes have an AD of 0, making them the most trusted. Static routes have an AD of 1. Dynamic protocols have higher values, like EIGRP at 90, OSPF at 110, and RIP at 120. Remember, the lower the AD, the more trustworthy the route. You can also manually change the AD if you want the router to prefer one route over another. Let's focus on static routes. Static routes are manually configured and give a router directions to reach a network or device that isn't directly connected. To configure a static route, you'll need 3 things: the destination network address, the subnet mask, and either the next hop IP address or the exit interface. Static routes are especially useful in smaller networks where things are simple and predictable. While they aren't practical for large, complex networks, they provide a strong foundation for understanding routing as a whole. Now, we'll configure IP addresses on the 2 routers and the PCs in our network. After that, we'll set up static routes so each router knows how to reach the networks it's not directly connected to. First, we'll start with router 1. On interface G001, we'll assign the first usable IP from its subnet. Then, on G000, which connects to the point-to-point link, we'll assign its first usable IP. Now, let's move to router 2. On interface G001, we'll assign the first usable IP from its subnet. Then, for G000, on the point-to-point connection, we'll assign the second usable IP. Now, let's configure PC1. We'll assign it the second usable IP address in its subnet, and we'll set the default gateway to the IP address we gave the router interface that connects to its subnet. For PC2, we'll do the same process. Assign it the second usable IP in its subnet, and set its default gateway to the router interface that connects to its subnet. Now, let's configure a static route on router 1 so it knows how to reach the remote network connected to router 2's G001 interface. We're telling router 1 to get to the network 192.168.20.128. Send traffic out of your G000 interface. Now, we're going to repeat the process on router 2. We'll tell it to reach the 192.168.20.96 network, send traffic out of your G000 interface. Now, we'll test connectivity by sending a ping from PC1 to PC2. Don't worry if the initial request time out. The router and the switch are completing the ARP resolution. After that, we should have successful replies. Now, let's check the routing table with the command show IP route. We should see the static route we just configured, indicated by the letter S. We'll also see two connected routes, which represents the networks physically connected to this router, and two local routes, which are the specific IP addresses assigned to the router's own interfaces. Thank you for watching. Make sure to subscribe. See you all in the next video.